Okay. Hi, everyone. So it's Friday. I think what people say is TGIF, I think. So thank goodness it's Friday. So with the exams, I am starting to make progress, finally. I got two questions graded. So I'm going to do, so again, I'm going to do as much, I'm going to work as hard as I can to get it back to everyone by early next week. Okay. So we have that. Let me see. There is homework again that's on Lumen. All right. There's homework and a quiz that both due tomorrow by 11:55 p.m. And again, as a reminder, I've said this before. If you miss a homework or a quiz for whatever reason, don't be afraid to email me. And as long as it hasn't happened repetitively, I'm more than happy to open up a homework for you or a quiz, one that you missed, I mean. Okay, I'm more than happy to do that. I understand life intervenes. I mean, look, I'm a little behind. I'm behind in grading, and I'm not happy with myself about that. Okay, I like to get things back to people, the graded exams that is, within a week. But unfortunately, that hasn't happened. So, but again, if you forget to hand something in for whatever reason, let me say it this way: if you did not hand in a homework or quiz for whatever reason, don't be afraid to email me. Okay. All right. I mean, if you don't email me, there's nothing I can do. So, all right. So we have that. Are there any questions at all? Okay. All right. Well, in that case, let me start lecturing. I did email everyone the notes. Okay. So it should come up. Ah, there it is. Good, good. Okay. All right. Okay, so last time, let me see something. If you can't see it or you can't hear me, just speak into your microphone, I mean. All right. So we did a few different things last time, right? The first thing we did was we saw this notion of simple interest. And again, the idea with simple interest is basically the interest, if it's a loan, if you borrow money somehow from a bank or for a friend, and both of you agree to pay back with simple interest, they calculate the interest at the beginning of the loan, in the beginning of the loan period, I think that's what they call it. And that amount, that interest is added on each year, the same amount as we saw last time, okay? That interest, it's a percentage of the starting balance. Now, how do you get that percentage? Well, that's what this R is here, the annual percentage rate. And again, this is how you get the total interest paid in 1 year. And essentially with simple interest, that total interest doesn't change. They keep adding that on to the balance. And these were the formulas that we had. So I just wanted to remind you, they are in the notes. Okay, they are in the notes, as we know. We also have compound interest, okay? Remember, with compound interest, okay, that in that case, they do calculate the interest at the beginning, of the loan period using R, just like with simple interest. But with compound interest, each year or each month, each day, how often it's compounded, you're recalculating the amount of interest. So you're not adding on the same interest to the balance each year, each month, each day, or whatever. With compound interest, instead what you're doing is you're recalculating the interest. We've seen this. These are the formulas, right? This was for simple interest. The total amount you'll have in the balance will be P0 plus I. P0 is the initial balance. I is the interest. And with compound interest, this is the balance you'll have after, T years. And remember, N is how often it's compounded. How many times, it's compounded in a year. And each time it's compounded, remember, you're recalculating the interest. That's the whole idea. This is an exponential function, actually. Here we have exponential growth. So this is an application of stuff from chapter 4. All right. Okay, so we did some calculations last time as well. I think we actually did these calculations, or might have been very similar. But either way, let's suppose you have $1,000, in an account, and the APR, that's that's the annual percentage rate, is 10%. And if you want to know how much you'll have after a year, depending on the compound period, you can do these calculations. So if it's compounded annually, once a year, right? What will happen is you'll have this amount after 1 year. That should be an equal sign. So let me see if I can fix that quickly. There we go, much better. Sorry about that. So that's $1,100. That's how much you'll have after 1 year, right? In this case, N is how often it's compounded in a year, right? So N is how many compounding periods there are in 1 year. N is 1. R is the APR, but you convert it to a decimal, so it's not a percent. When you do that, you get 0.1. P0 here is the initial balance, which in this case is $1,000. Okay, good. So if it's compounded annually once a year, you'll have this amount. Now remember, also, we had this idea of percent change, which you can get from basically relative change. Well, essentially it's the relative change, but you're converting it to a percent. So how do we do that? It's the ending amount minus the starting amount, and then you're going to divide by the starting amount. That's exactly what we're doing. Ending amount minus starting amount over starting amount. Okay. Now, if you were to calculate this, you would actually end up getting 0.1, which is 10%. Okay, well, that's the same as the APR. Okay, so the amount in the account went up by 10%. What if we compounded it, though, quarterly? That means, again, 4 times per year. 4 times per year. Okay? Well, in that case, right, N is 4. So we're using N in our formula, 4, 4. But in that case, we're going to have more money in the account than compounded annually, right? Because you're calculating the interest more frequently. So you're adding in money more frequently. Now, in this case, what would the percent change be? Well, in other words, by what's the percent increase in the balance? Well, we take the ending amount, minus the starting amount divided by the starting amount. Okay? And that becomes this, which is about 10.3%. Notice this is bigger than the APR. And you could do the same thing for compounded monthly. Namely, in this case, N is 12. You're compounding it once a month. And the calculation, you get this. Just direct calculation. You can use Desmos. They have that kind of calculator. And anyway, the percent increase in the balance, right? Ending amount minus the starting amount over the starting amount. This turns out to be 10.5%. Then you compound daily. That's, once a day, 365 days in a year. That's what we're assuming. I know there are leap years when I think there's 366 days then, but that's a different story. But anyway, when we compound daily, right? Okay. In that case, you'll get this amount. Here I just rounded to more decimal places just to illustrate that it's not going to be the same as this. And really the bottom line is summarized all this in the table. The bottom line is this. These percents, except for the first one, are not the same. Here. These percents are not the same as the APR. So if it's compounded annually, then the percent increase is the same as the APR, but not these times though. Well, what's going on here? Well, this brings us to the notion of the APY. This is what people call the annual percentage yield. By definition, it's really just a percent increase in the balance after 1 year. So it's the ending balance or the balance after 1 year minus the starting balance or the starting principal. Again, starting principal, it's really the same as the initial amount divided by initial amount. That's what the APY is. I mean, there is a general formula, and that's what I'm deriving here. Right? This was the amount in the account after 1 year. So basically, I'm going to compound interest, compounding. I'm just using t equal to 1. And that's, oops, sorry, wrong button. That's how I get this. You know, what's the starting amount? Well, that's what P0 is, right? That's what, here it is, the principal or the starting amount. Starting principal, same thing. And you're dividing by that. Well, basically, you could just divide into each term in the numerator. Okay, I know I didn't show the calculation, but it's really not that terrible. And when you do that, essentially the P0s cancel and you're left with this. And that's what our formula for the APY is. Again, this is when T is 1 after 1 year. Just up here.